ஏம்மா தம்பி, இதோடைய மூடியங்க. Pero வந்தவன்
Good afternoon, ma'am.
ஆளை பார்த்தா சொல்ல மாட்டேங்குது.
Shamla ma'am, shall we start the session?
Yes, ma'am.
The difference between the impossible and the possible lies in a person's determination. With this note, a pleasant afternoon to everyone. It's my privilege to extend a cordial welcome to all on behalf of Faculty of Education, Dr. MGR Education and Research Institute. It's my pleasure to welcome everyone to this third day workshop on SPSS, hosted by a renowned person, Dr. A. Shamla Devi, Assistant Professor, School of Education, University of Madras. I also welcome all the principal, professors, research scholars, students from various colleges. Now the session is yours, ma'am. Please.
Good afternoon, everyone. So in the last class, we discussed about how to create a data file in SPSS and also how to enter the values in SPSS. In SPSS, we have two windows, data view and variable view, and how to feed the data in the variable view and thereby entering the data in the data view. And also we discussed about how to import the data from Excel to SPSS. As I told already, importing the file from Excel to SPSS will be much more easy than directly entering the values in SPSS. And then we also discussed about how to export the data from that is export the output from SPSS to Word document or Excel, or if we can copy the table itself. If we want only the table, that alone we can copy and paste it wherever we want to paste. And we discussed about the basics of SPSS, and then we moved to the analysis part. So we started with descriptive statistics, that is measures of central tendency and measures of dispersion. So under central tendency, we discussed how to analyze mean, median, mode. And under dispersion, how to analyze range, quartile deviation, standard deviation, and then that's it. So these are the things we discussed under descriptive statistics. And next, second one is inferential statistics. So under inferential statistics, we discussed about t-test. So only t-test. So under t-test, there are many types of t-tests. So we discussed the various types of t-test and what are the assumptions for analyzing the particular type of t-test. So we discussed nearly about 3 types. So one sample t-test, and then independent sample t-test, and then paired sample t-test. So one sample t-test means if the population mean is known, then we will be doing one sample t-test. So with single sample mean, we will be comparing the sample mean to the population mean. So that is one sample t-test. And independent sample t-test means if the demographic variable is classified into or divided into 2 subgroups, that is gender means male, female, locality means rural, urban. So if it is divided into 2 subgroups, in that case, we will be performing t-test. Okay, so that is independent sample t-test. And the third category is a paired sample t-test or matched paired test. So while doing experimental research, we are supposed to compare the pre-test and post-test scores of the students. So in that case, in order to compare the pre-test and post-test scores, we will be doing paired sample t-test. So these are the various types of t-test we discussed in the last class. And today I plan to discuss about, so the first day itself, I told you about normality, right? So how to check the normality of the data, how to find out whether the distribution is normal or not. So first we are going to discuss that, and followed by F-test. So under inferential statistics, F-test. Okay, so F-test is also known as ANOVA, analysis of variance. So we will be discussing how to analyze this F-test and then correlation. So in correlation also, there are many types of correlation, but in today's session, I will be focusing only on product moment correlation, because that is the technique which is very apt for large size sample or for a normal distribution. So I'm going to discuss only on the product moment correlation. And in product moment correlation, we can do it in different ways. Okay, so those things we are going to discuss. So with that, I will be winding the class. And also I will touch what is meant by regression. Okay, so with that, let me move into this today's session. Okay, so in the first class, I told you what is meant by normal distribution, right? Can anyone text in the chat box what is meant by normal distribution? Yes. When we can easily classify the data. Yes, very good. Mean is equal to median is equal to mode. Okay. Sharika, you're right. Then, any other answer? See, the properties of normal probability curve. One property is mean is equal to median is equal to mode. So for a normal probability curve, the 3 measures of central tendency, that is mean, median, mode, all everything will be at the same value. Okay, and it is a bell-shaped curve. That is also we discussed. Okay, so let me share my presentation. Can you able to see my screen?
Yes, ma'am.
Thank you. Okay. So what is meant by a normal distribution? So a normal distribution, it is also known as normal probability distribution or a Gaussian distribution, is symmetrical in nature. So symmetrical in nature means if you cut the normal distribution in the middle, it will cut into 2 equal halves. So that is known as symmetrical. Asymmetrical means it will not equal. When you cut the normal probability curve in the middle, you will not get equal proportions of the parts. So that is asymmetrical. But a normal probability curve is symmetrical in nature, and the data near the mean is more frequent in occurrence than data far away from the mean. So that I already discussed, that we discussed. That is, so here, so this is the center point. So here more values will be falling under the mean value and towards the center than the extreme ends. So towards the extreme, only very few values will fall under the extreme, and on the middle, most of the values will be falling under the mean value nearby the mean or under the middle value. So that is called what? Normal distribution. So why it is called normal distribution? Because any traits or any attributes or any characteristics if you draw a probability curve for the set of cells, you will be getting a normal distribution. So that is what? That is law of nature. Okay, so for any attribute, if you draw a graph, you will get a normal. So this is called normal distribution. Likewise, in your research, for your variable, let it be academic achievement or learning style or job satisfaction, mental health, whatever the attribute or whatever the variable, if you draw a curve, you should get a bell-shaped curve. If not, so what it means? Suppose if you are not getting a bell-shaped curve, so it means somewhere you did mistake while collecting the data. Okay. So how to minimize this error? So in order to minimize, only if the error is more, you will not get the normal distribution. So in order to minimize the error, you should increase the sample size. So once you increase the sample size, obviously, automatically your error will get decreased. So this is how you can minimize the error. Okay, now let's see how to check the normality of the distribution. Yes. So let us discuss the assumptions to check the normality. So the first one is the data should fall around the mean values. So already we discussed, no? So not all, most of the values will be falling around the mean values, and skewness is equal to 0 for a normal curve. So in order to test the normality, the thing is the skewness will be around 0. Skewness means what? If instead of getting a symmetrical curve, you will be getting an asymmetrical curve. So asymmetrical curve means it will be skewed or leaned towards positive side or lean towards negative side. So if there is a skewness, then it is not a probability curve. So for a normal curve, the skewness will be 0 and kurtosis will be 3 for a normal curve. And for we have 3 types of kurtosis: platykurtic, mesokurtic, and leptokurtic. So for platykurtic, the kurtosis value will be less than 3. For mesokurtic, the kurtosis value will be 3 because mesokurtic will resemble the normal probability curve. And if it is leptokurtic, the kurtosis value will be greater than 3. Okay. And next one is the data must be continuous. Yes. Only for continuous variable, you can check the normality. For academic achievement, for your scale variable. Scale variable means, I hope you understand. Academic achievement, learning style, mental health. Only for scaled variable, you can analyze this normal, you can do with normality testing. For discrete variables like gender, medium of instruction, medium of what else? Order of birth, age, salary. For this discrete variables, you can't do this normality testing. So only for continuous variable, we will be doing the normality testing. And then, so we have 2 tests for the normality test. We have 2 tests. One is Kolmogorov-Smirnov test, and another one is Shapiro-Wilk test. So when to use Kolmogorov and when to use Shapiro test? If the sample size is less than 30, that is for small size sample, you will be doing Kolmogorov-Smirnov test. If the sample size is more than 30, then we will be doing Shapiro-Wilk test. So that is the only difference between the 2 tests. So based on the sample test, we have to choose the test for normality. Okay. So these are the assumptions. So very simple thing is, in order to check the normality, to test the normality, you should have a continuous variable. If it is a continuous variable, then you can go for normality testing. But the thing is, you have to check the sample size. If it is large size sample, then Shapiro test. If it is small size sample, Kolmogorov test. Okay. Okay, now. Okay. So now I'm just going to open I'm going to import the Excel file to SPSS. Okay. So if you want, you can check the steps one more time because last day itself we discussed, but still. So file, open, data. So under directory folder, I'm having my Excel sheet, but still it's not opening because the file type here is SPSS. So I have to change the file type to Excel. Okay. So now the Excel file will be shown. So I have to check this master table. Select and then open. So I'm having the master table in sheet 1. So, okay. So this is my variable view. So I have to clear the serial number because I don't want that. So I really want to clear it. Okay, so this is the variable view and this is my data view. So under variable view, I don't know, we have to do some preparatory work. Only then we can do the analysis in SPSS. So only limited characters is allowed under name and space is not allowed here. So we have to give the short form of our demographic variables under name. But under label, we can we can type the demographic variables with space. So I'm typing my gender here and we have to assign the values. So 1, boys, and number 2, girls. We have to add. Okay. And next one is type of management. So type of management. Number 1, it is government. Yes. Number 2, aided. And number 3, private. And okay. Okay. So I think 2 is enough. Only with these 2 demographic variable, I'm going to do the analysis. So I'm not going to give the values for medium of instruction and family type. Okay. And these today, in addition to the 2 continuous variable, I have added one more continuous variable, that is study habits. So this is home environment dimensions. So home environment 1, that is dimension 1, dimension 2, dimension 3, dimension 4, and dimension 5. And this is home environment grand total. Okay. And this is my academic achievement score. And the last one is study habits. So I am having 3 continuous variables, that is scaled variables. So apart from the demographic variables, all other variables should be named as scale. The demographic variables I have named as nominal. Okay. So now I have prepared the variable view. And if you want, you can check this in the data view also. Okay. So now let's start the normality testing. So to test the normality, we should go to analyze, descriptive statistics. Under descriptive statistics, we should move to descriptor. Explore. So analysis, descriptive statistics, and then explore. Just click that. So we have to shift the continuous variable and not the discrete variable, right? So let me shift academic achievement. First, let me shift academic achievement to the dependent list. And under statistics, okay, let it be. And under plots, yes. So this is very important. So this under statistics, if you want, you can check the descriptive column, because if you want mean and standard deviation, then you have to check this descriptive column. Continue, and then you have to check plots. Here, I want histogram, because only with the help of histogram I can check whether it is a normal probability curve or it is skewed or not. I can check. So I want the histogram as well as I want normality plots with test. So you have to check both the histogram and normality plots with test. With that, continue. Okay. Okay. So now the output will be generated. Yes. See, here the skewness is minus 0.124 and the catalysis value is also minus 0.511. So here the under test of normality, we have both the tests, that is Kolmogorov-Smirnov test and Shapirov test. As I told already, the first one is for small size sample. So we are supposed to check the values given and then Shapirov will test. Okay. So if you check the values here, what is the significance value here? The significance value is that is it is nothing but the level of significance. So the level of significance value is 0.00. So what it means, what it interprets? Can anyone type in the chat box? Here, the significance value is point. Yes, it is 99% significant. Okay. 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 So one more thing I forgot to explain. Significance. So data is normal. No, the data is not normal. I'll tell you why. Because see, first of all, before doing the analysis, we are supposed to formulate the objectives and hypotheses, right? So now tell me, for a normal, in order to check the normality of the test, what type of hypothesis we have to formulate? You can post your answers in the chat box. Okay. The data is not normally distributed. Okay, Sharika has given the answer as the data is not normally distributed. Any other answer? Yes? Okay. See, actually, non-normal data, Vijay. Okay. See, actually, you know, the first class itself, I told you, you have two options. One is you can go for directional hypothesis, and second one is you can go for non-directional hypothesis. To be on the safer side, I told you to formulate non-directional hypothesis, that is nothing but null hypothesis. But if you have proper evidence, then you can go for directional hypothesis. Just now I told you that whatever the attribute, whatever the characteristics you plot graph, you will be getting a normal curve. So that is law of nature. So it is highly proven that for any data, if you draw a graph, you will get a normal distribution. So we have enough evidence for this, right? So we can go for formulating directional hypothesis. Okay, is it clear why we are formulating directional hypothesis in order to test the normality? Yes. So let me show the PPT. Okay, so how we have to formulate the objectives for us to check the normality? The objective comes like this: to find out the normality of home environment of 9th standard students, or to find out the normality of study habits of 9th standard students. So this will be your objectives. And then I'm going to frame the directional hypothesis and not null hypothesis, because we have enough evidence that for all the attributes and characteristics, if the population if the sample size is more, and if you really genuinely collected the data, you will get normal probability 1 day. So here I'm going with directional hypothesis. So the home environment of 9th standard students is normally distributed, or the study habits of 9th standard students is normally distributed. So I'm formulating a normal distribution. So I have taken two continuous variables. One is home environment and another one is study habits. So with this objectives and hypothesis, let me move to the SPSS analysis part. Okay. So let me do it one more time. Analysis. Sorry, descriptives. Under descriptives, you have to check explore. Under explore, dependent list, I'm going to shift two variables, that is home environment, grand total, and then the study habits. So I'm going to check the normality for two continuous variables. One is home environment and another one is study habits. So let's do the dependent list, and as usual, statistics, I have already checked the descriptive column, and then for plots, I have to check the histogram and normality plots with test. Continue and then OK. Okay, now let us check the output. So this is for, yeah. So GT is nothing but the grand total of home environment. Okay, so for this, the skewness value is 0.08. So it is around 0. And cutoff value is 0.187. And for study habits, if you check the skewness value, it is minus 2.306 and cutoff is 6.5. Okay, let me check the table value here. Yes, for home environment, the significance value is 0.3 and for study habits, the significance is 0.00. Now tell me, the significance is 0.3 for home environment. So what it tells? Yes, come on. Interpretation part. Which part? Okay, I'll explain again. Can anyone give me the answer? Now the significance value is 0.38. The data is normally distributed. Yes, because see the significance, if you multiply this 0.389 into 100, you will get 38, right? So 38, the error is 38, which means, so if it is greater than 0.05, we will be accepting the null, accept the hypothesis. So we already formulated what type of hypothesis? Directional hypothesis. So the home environment data is normally distributed. And for study habits, the value is 0.00, which means it is less than 0.05, which means we have to reject the hypothesis which we formulated. So rejecting the hypothesis means what? We have formulated as normally distributed. So we are rejecting means we should go with alternate hypothesis, which means it is not normally distributed. Okay, let us check the histogram here. See, this is the histogram for home environment. See how the graph has come. If you, so it is a normal curve, right? It is a bell-shaped curve. You will get a bell-shaped curve for this data. So, which means the data are normally distributed. If you check this XX plot, QQ plot, this is also very important. So in QQ plot, if you see the plot which we have marked, the marked plot should coincide with the straight line. If we go along with the straight line, which means the data is normally distributed. If it is not go with the straight line, which means it is asymmetrical or not normal. So let us check. Let us check for the other one, study habits. See how the histogram has come out. So this is not normal, right? It is skewed. It is leaned towards positive side. So it is called negative skewness. Oppositely, we have to call. So now this probability curve is skewed. So it is not a normal curve. Similarly, if you check the QQ plot, see the plots go away from the straight line. It is not along the straight line. So this clearly shows that for study habits, the data is not normally distributed, but for home environment, the data is normally distributed. I hope now you understand how to check the normal. Now what I'm going to do is, I want only this table, okay? So let me copy this table. And I'm going to my PPT. Yes. So I have not drawn the table here. With this, we can easily get. So as I told, it is large size sample and hence you have to check the values of Shapiro-Wilk test. So from the above table, it is observed that the significance value for home environment is greater than 0.05. So we have to accept the null hypothesis. So what? We have to accept the hypothesis. So accepting the null hypothesis means the home environment of 9th standard students is normally distributed. Okay. Similarly, for the second one, this is the p-value. Okay. So here the probability. So from the above table, it is observed that the p-value for study habits is less than 0.05. So we have to reject the hypothesis. So rejecting the hypothesis means for study habits, I have to reject this. So the study habits of 9th standard students is not normally distributed. distributed. So this is how you have to interpret. I hope you understand how to check the normality of a distribution and how to write objectives and hypotheses, as well as how to write the interpretation with the help of the table values. Is that clear? Yes? If it is clear, I will move on to the next one. Yes. Thank you, Shilpa. Okay, so now we have checked the normality of the distribution. So see, actually my data, I have somehow I copied and pasted, so it is not normal. But if you conduct the research genuinely, and if you collect the genuinely, definitely you will get a normal curve. So nothing to worry about it. If it is not normal, means what you have to do? At least you have to increase the sample size. Once you increase the sample size, you will get a normal curve. After increasing the sample size also, you are not getting normal curve, means whether you may did some mistake in the items, formulated items may go, sometimes it may goes wrong. Sometimes the students or your sample may not understand the items you have formulated. So you have to check that. Okay. So now let's move on to the F test. Why it is rejected means in the last class we have discussed enough about it. If the p-value is greater than 0.05 means we have to accept the hypothesis. If the p-value is less than 0.05 means we will be rejecting the hypothesis. So that is the only rule. So with that rule, we accept and we reject. Okay. So next one is, this is over, right? One-way ANOVA. So it is also known as F test. Okay. So one-way ANOVA is also known as F test. It is used to compare the mean scores of more than 2 subgroups. See, that is the only difference between t-test and F-test. In t-test, we are going to compare the mean scores of 2 subgroups. 2 subgroup means medium of instruction, Tamil medium, English medium. So it has 2 subgroups. So when we are going to compare the mean scores of 2 subgroups, it is t-test. If suppose you have more than 2 subgroups, type of the management. So it is government aided, private. It is more than 2. In that case, we will be doing F test instead of T test. But in both the cases, we are going to compare the mean scores. Okay. So that is same. But since the level or since the factors increases, there we have only 2 factors in gender. But now under type of the management, we will be having 3 factors. So it is more than 2. So we have to choose ANOVA. Okay. So it is used to compare the mean scores of more than 2 subgroups. It can be 3, 4, 5, 6, etc. So what are the assumptions for one-way ANOVA? So first one, of course, the data should be normally distributed. Okay, if the data is not normally distributed, so if it is normally distributed in the sense we have to choose parametric test. So ANOVA comes under parametric test. If the data is not normally distributed, you have to go for non-parametric test. Tell me what is the equivalent non-parametric test for ANOVA? Yes, can I have the answer in the chat box? Mann-Whitney is for t-test. Okay, so Mann-Whitney is the equivalent non-parametric test for t-test. Yes, Kruskal-Wallis test. Yes, very good. Anbumala, Sharika, you're right. So the Kruskal-Wallis test you have to choose. If it is not normal, if it is a non-parametric test means you should go with the Kruskal-Wallis test. Okay. Somebody has asked in the chat box, is there any way to convert the non-normal data into normal data? See, the only thing, if you don't have time means you can do this, you can try. If it is okay, if it comes good, you can go. Only thing is you can increase the sample size. Suppose my sample is 200. When I check the normality, it is not normal. So I have to increase the sample size to 300, 400, 500. So after increasing the sample size, you check the normality. Okay. If it is normal, it is your good luck. You can proceed with that. If it is not normal, then again you have to check the questionnaire or the scale, the tool you have developed. as well as whether you have collected the data properly, the questions are understandable for your sample or not. So those things you have to check again. Okay. Okay. So normal distribution, and the second one is yes. So here we are going to use two data. One is two variable. One is continuous variable and one is discrete variable. So the continuous variable means it should be either interval scale or ratio scale. If it is a discrete scale means it should be nominal scale. So nominal scale is more than two subgroups. So for continuous variable, I am going to take academic achievement, and for discrete variable, I am going to take type of the management. So the type of the management has three subgroups, that is government, aided and private. So it is more than two subgroups, and hence I'm going to do ANOVA. If at all no, then I have to go with t-test. If it is limited to two subgroup means we have to choose t-test. Okay. So with that, we are going to do the analysis for yes. Analyze, compare means in that one way ANOVA. So in the last class, we already discussed about how to do the analysis for one sample t-test, independent sample t-test, and paired sample t-test. See, actually, one more thing I forgot to share yesterday, that is the t-test, this t has to be written only in small letter. Okay, because here the people who develop the software, they may not know the history behind the t-test. So they have developed it as T capital letter, but T has to be written in small letter, and for F test, F has to be written in capital letter. Do anyone know why? What is the reason we have to write the T in small letter and F in capital letter? Yes. Okay. See, actually, the T test was developed by Gosset. Okay. So William Pelly Gosset. So he is the one who developed this T test. And the F test was developed by Fisher. Okay. Actually, Gosset was the student of Fisher. So when Fisher was very popular in developing the kind of formula, the same time his student Gosset is also developed the t-test. So when his teacher is there, he don't want to use his name as Gosset. So he written many articles and formulas in the name of student test, because in order to respect his teacher, he wants to use he don't want to use his name Gosset. So some people say Gosset, he has taken the last letter T. Instead of taking the first letter, he has taken the last letter. So that T has to be written in small letter. For Fisher, we have taken the first letter, and hence F has to be written in capital letter. So never ever commit this mistake. Always you have to write the T in small letter and F in capital letter. Okay. Okay. So analyze, compare means one way ANOVA. So in one way ANOVA, under dependent, I have to shift the continuous variable. So that is academic achievement. Let it be academic achievement. And under factor, I have to shift the discrete variable. So discrete variable already I have told we are going to do for type of the management, because it has more than two subgroups. Okay, over. And then I don't want this. Okay, options. If you want descriptive, you can check the descriptive. If you want mean and standard deviation value, then go to options and check the descriptive. Continue. Okay. So now this is the table values for F test. So descriptive, we have checked the descriptive and hence we are getting this table. If not so, you will not get this table. Okay. Unless and otherwise you check the descriptive column, you will not get this table. So here we are getting the number of government, aided and private school students, their mean value as well as their standard deviation value. And this table is very important. So with this table only we are going to interpret the results. So between groups means it will compare government and government aided, government and private. So between groups as well as within groups, within all the three. So it will do between and within. So that is analysis of variance. Okay. And we have sum of squares and degrees of freedom, mean square. square. So only when we do the analysis manually, you came to know what is sum of squares and what is mean square. So now I'm not going to touch that. So we want the F value. So here the F value is 4.821 and the significance value is 0.009. So what it means? So this is, the p value is 0.009. So what it tells? Yes? Can anyone type the answer in the chat box? Not significant. See, the p value is 0.00. It is less than 0.05 or greater than 0.05. Or you simply multiply the p value into 100, which means what? You will get 0. So it is 0% error. So it is significant. Yes, it is significant, and hence we can reject that null hypothesis. Okay, so let me go to my PPT and I'll show you. So how to formulate the objectives for F test? To compare the mean score among. So we are going to compare among three groups. If it is two, means you have to write between male and female, between rural and urban, between Tamil medium, English medium. So here we have more than two subgroups, and hence I'm using the word among. So to compare the mean scores among government, aided and private school students in their academic achievement, or 9th standard students in their academic achievement. So this is my objective. And what is my this is my null hypothesis. There is no significant difference in the mean scores among government, aided and private school students in their academic achievement. So this is my null hypothesis. So now our p value is less than 0.05, which means we have to reject the null hypothesis. So I have to reject this null hypothesis. Rejecting means what? We have to choose alternate hypothesis. So the alternate hypothesis is there is significant difference in the mean scores among government, aided and private school students in their academic achievement. Okay. So the table will be like this. The source of variance of one-way ANOVA of school students in their academic achievement. Okay. So now let me copy the output. So let me just click, right click, copy. And I'm going to paste here. Okay, between groups. So this is between groups and within groups, sum of squares. So the sum of squares value is, so let it be, I'm rounding to 2 decimal places. And within group, and also the total. And degrees of freedom, between groups, we are going to compare only 2. So it is 2. And within groups, so here it is. So 397. And the total DS is 399. So for degrees of freedom also, we have separate formula, and I'm not going to touch it because everything will be accumulated in the SPSS table. So no need to go and do the manually calculating the degrees of freedom. So you just take down the values as such given in the SPSS table. So next one is mean score values of between groups and mean square values of, here it is, 143.3. Okay, and the F value is 4.821. So the F value is 4.821 and the significance value is 0.009. So here, see, last year I forgot to tell you. So we can check both for 5% level of significance and 1% level of significance. Now this p value is significant at 5% level or at 1% level? Come on, give. Yes, 1% level of significance. Very good. So if it is significant at 1% level, we have to give 2 stars. If it is significant at 5% level, we have to give 1 star. Okay. So now I'm just giving 2 stars because it is significant at 1% level of significance. So now the remark under remark column, it is significant. Yeah. Okay. So if it is not significant, means nothing to worry. But there is significant difference among the group. Among the group means it can be between government and aided, or government and private, or aided and private. So sometimes these two groups there is significant difference, and that we have to find out. That is called the post hoc test or post ANOVA test. Okay. For F test alone, we will be doing this kind of post hoc test. If there is no significant difference, then we can leave just like that. Now this is not needed. Just deleting this. Okay. So if there is no significant difference among the group, then we can leave as such. But here there is significant difference between among the groups. So we have to find between which group there is significant difference. For that, we have to do post hoc test. Okay. So for that, let me move to my SPSS. Okay. So for that, so analyze. Again, compare means one way ANOVA. So here we have post hoc, right? You just check this, and here we have many tests. Like some people will be doing Skiffy test, Tucky test, Duncan test, Waller-Duncan test, LSD, least square difference. So many methods are there. So which you want to use, you can use. Okay. I ask my students to go with LSD, or let us do Duncan test also. Okay, I'm going to check with 2 tests. One is LSD and another one is Duncan test, and continue. Okay. If you want, you can check whatever the test you want to check, you can do that. But here, for your understanding, I'm going to check only 2 tests. One is LSD and another one is Duncan test. Here the significance is 0.05. Let it be. So continue and then okay. Now let's check the post hoc table. See. So this is the LSD table and this one is for Duncan test. So first let me check for LSD. So here, this is government, right? Between government and aided, the significance value is 0.02. Okay. And between government to private, the significance value is 0.07. Similarly, between aided and government, the significance value is 0.02. That we already know, right? And between aided and private, the significance value is 0.174. And private and government, private and aided, that we already know. So this is the significance value. Now tell me, between which group there is a significant difference? Come on. Between which 2 groups we have significant difference? Yes. Why we conduct post hoc test? Because there is significant difference among the 3 subgroups, right? We have 3 subgroups: government aided, and private. So now I want to check between which 2 groups, this group or this group or this group. So between which 2 groups there is significant difference. For that, we are doing post hoc test. Very good. It is between government and aided because government. So Sharika, Tengoli, you are absolutely right. Okay. So between government and aided, the significance value is 0.02. Now it is significant at 5% level or at 1% level? Yes? It is, yes, it is significant at 1% level. Now between government and private, the P value is 0.7. 0.7 means the error percentage is how much? What is the error percentage for government and private? It is, yes, it is 7% around. Okay. And for yes, 7.9. Very good. Absolutely correct. So 7.9% error is there. Similarly for private and for which we have. Similarly for private and aided, we have 17% of error. So it is not significant. Okay. So there is a significant difference between only one group, that is between government and aided. Between government and aided, we found significant difference. So how to interpret this in the table? So let me go to my table. So okay. See, actually, I have to wait. See, according to me, government is group 1. Okay. And aided is group 2. And private is group 3. So now there is a significant difference between government and aided. So under group differ, I have to, within parentheses, I have to write 1, 2. So this 1, 2 shows that there is a significant difference between government and aided school students in terms of academic achievement. Is that clear? Yes. Yes, it is between government and aided. Okay, is it clear? Okay, so how we are supposed to write the interpretation for this? So from the above table, it is observed that the p-value, so the p-value here is 0.00. Okay, so I have rounded to 2 decimal places, so it is 0.00. So the p-value is less than 0.05 or 0.01. Let it be. Okay. So from the above table, it is observed that the p-value is less than 0.01. Hence, the null hypothesis is rejected at 1% level of significance. So there is significant difference between, so you have to reject the null hypothesis. So instead of there is no significant difference, you have to write there is significant difference in the mean scores among government aided and private school students in their academic achievement. Okay. So from the above table, it is observed that the p-value is less than 0.01. Hence, the null hypothesis is rejected at 1% level of significance. So there is no significant difference in the mean scores among government aided private school students in their academic achievement. And further, the post hoc test shows that there is significant difference between government and aided school students in their academic achievement. That's all. So this is how you have to write the interpretation for the table. Okay. So these values we have copied as such in the table in SPSS, and we have filled the F value as well as the P value, and then we have written the remarks. And since there is a significant difference, we have to do post hoc test, and then we have to find out the group difference, which group there is significant difference. So it is between 1 and 2. So if possible, you write what is 1, 2, 3 under the table. Okay. So 1 is government, 2 is aided, and 3 is private. So you have to write that. Only then we can understand there is a difference between government and aided. Okay. Okay. Any doubts? Can clarify now. Yes, two-way ANOVA. See, two-way ANOVA, I'm not going to take that now because it is little bit difficult to understand. Here we have taken one continuous variable and one discrete variable. So that is one-way ANOVA. In two-way ANOVA, we will be taking two discrete variables and one continuous variable. That is academic achievement. Along with academic achievement, we will be doing the analysis for gender, for suppose gender and type of the management. So gender is having two subgroups. Type of the management is having three subgroups. So it is 2 cross 3 factorial design. Okay, it is called 2 cross 3 factorial design. So it is two-way ANOVA. Similarly, for three-way ANOVA, you will be using three discrete variables. So this is how it goes. Okay, and the analysis is also similar to this one, but there we won't be calculating the post hoc test. How do we use the value of F for interpretation? See, Sharika, actually during the year 2007, when I was doing my M.Ed, during that time we do the interpretation with the help of F test. Okay, this is calculated F value. Similarly, you have to check the table value behind the statistics book. So there you will get the table value for F, and then you have to check the calculated F value with the table value. So if it is greater than or less than equal to the calculated value, table value, in that interpretation, we will be writing whether it is significant or not significant. And that one is outdated. So now we are writing the interpretation with the help of P value. So no need to worry about F value. Just for the sake of writing in the table, you write the F value. But with the help of P value, you try to write the interpretation. So writing interpretation with the F value is outdated. So you don't need to worry about it. Okay?
Ma'am, I have a doubt.
Yes, please.
Ma'am, in the PPT, you have written there is no significant difference in mean scores, no? But there is a difference, right?
Yes.
That's why we are doing post-hoc.
Yes.
The null hypothesis is no significant difference. So, but here you have written there is no significant difference in mean scores. Yeah. It should be.
Yeah. Okay, thanks. I just copied that, so I forgot to delete it.
So it should be there is a significant.
Yeah,
okay,
yes.
Got it.
Okay, thanks. So there is significant difference in the mean scores among government, aided and private school students in their academic achievement. So we are calculating the post hoc test, and further with the help of post hoc test, we are interpreting that there is a significant difference between government and aided school students in their academic achievement, right? Any other clarification? Okay. So now I'm going to correlation. Okay, so F test is over. As I told, two-way and three-way. Once you understand this one-way ANOVA, two-way and three-way will be very easy for you. Okay, so the simple thing is here one continuous variable and one discrete variable for one-way ANOVA. If it is two-way ANOVA, you will be taking one continuous variable and two discrete variable. In that case, even if the discrete variables have two subgroups, we can take that into account. Okay. So gender and medium of, for example, gender and medium of instruction also you can take. So gender is also having two subgroups. Medium of instruction is also having two subgroups. So it is 2 cross 2 factorial design. You can go for three-way ANOVA. Okay, so it will take more time, so I'm not going to touch that. So let us move to correlation. Okay. So now the correlation. So in correlation, what actually we are doing is we are going to find out the relationship between the two variables. So it is used to measure the strength and direction between the two variables. So what does mean by strength? Whether, for example, whether the two variables are strongly correlated or weakly correlated or moderately correlated. So we are going to check the strength. Okay, strong, weak, or moderate. So that is strength. And next one is we have, and also we can check the direction. That is, if one variable increases, the other variable will also increase. So both the variables will move in the same direction. Or else we can say, if one variable decreases, the other variable will also decrease. So that is same direction or opposite direction. Anything is possible. So with the help of this correlation technique, we can find out the strength between the two variables as well as the direction in which the two variables are moving, either in the same direction or in the opposite direction. It can be in the positive direction or negative direction, upward direction or downward direction. That doesn't matter. But the same or opposite direction we can find out with the help of correlation. Is that clear? Or you want me to give some examples for this? Okay, I think it is clear. Okay, thank you. So we have three types of correlation, positive correlation, negative correlation, and then zero correlation, right? So positive correlation means what? Both the variables will be moving in the upward direction. For example, the practice, I'm taking two variables. If the practice increases, errors committed by the students will be decreases. So this is different one. Okay. If the IQ of the students is high, their achievement will also high. So now I have taken two variables, IQ and academic achievement. If academic achievement increases, IQ will also increase. If for some other student, if IQ is very less, then achievement will also be less. So these two variables are moving in the same direction, either in the upward direction or downward direction. So this is called positive correlation. Okay, so now negative correlation means what? If the practice time increases, if the child keeps on practicing grammar or something like that, so the error committed by the students will decrease. So when practice time increases, error committed by the students will get decreased. So both are moving in the opposite direction. So this is negative correlation. Zero correlation means we cannot say whether this variable influences the other variable. Why it differs, we can't say. There will be no correlation between the variables. For example, we can't say if the person is very fair, they will be very intelligent. So there is no correlation between the color, skin complexion and the intelligence of the person. So this is called zero correlation. So we have three types of correlation: positive correlation, negative correlation, and zero correlation. So here it tells us about the direction of the two variables, whether they are moving in the same direction or opposite direction or no. So that is what I'm going to tell in the next point. Okay. Okay. So let's see the next point. Both the variables should be normally distributed. Okay, because because product moment correlation comes under parametric test. What is the equivalent non-parametric test for product moment correlation? Come on. Can anyone type in the chat box? What is the equivalent non-parametric test for? Yes, Spearman rank correlation. Yes, very good. Thank you, Sharika. Okay, see, this product moment correlation is also known as Carl-Pearson correlation. Okay, so Carl-Pearson correlation or product moment correlation, both are same. Similarly, rank correlation or Spearman rank correlation, both are same. Okay, so both the variables should be normally distributed. For example, I'm taking two variables, means both the variables should be normally distributed. And next, one important point is yes, we should have two continuous variables. See, this is very, very important because in some Viva, I have seen students who have correlated between a continuous and a discrete variable. No way you can do that. Okay. Only you can correlate two continuous variables. Academic achievement, learning styles. Academic achievement, brain dominance. Job satisfaction, mental health. Emotional intelligence, academic achievement. So only between two continuous variables you can do this product moment correlation, not between one continuous and one discrete variable. So continuous and discrete variable only to compare the means, not for correlation. Okay, so please clarify that. So both the variables should be normally distributed and two continuous variables. Okay, then how to write the objective? So let's read that. So here I have given some 4 objectives and I will tell you how to write the hypothesis for these 4 objectives and how to analyze, do analysis for these 4 objectives. With that, we will wind up the session. Okay. So first objective is to find out the correlation between home environment and academic achievement of 9th standard students. So this is my objective 1. And the second one is to find out the correlation between home environment and academic achievement of boys and girls of 9th standard students. I told you that you can't do correlation for one continuous and one discrete variable. But if you have two continuous variables, then you can find the correlation in terms of gender. Okay, in terms of boys and girls, in terms of Tamil medium, English medium, in terms of rural and urban. But the base is you should have two continuous variables. With that two continuous variables, you can go for the subgroups, that is boys and girls, discrete variable. Okay, so this is your objective 2, to find out the correlation between home environment and academic achievement of boys and girls of 9th standard students is missing here. Okay, next one is to find out the correlation among home environment, study habits and academic achievement of boys and girls of 9th standard students. So students is missing here, but cut copy paste and list it somewhere. Okay, so this is my third objective. And the last one is to find out the correlation between home environment and its dimension and academic achievement of 9th standard students. So how these 4 objectives differ from each other? In the first one, I have taken only 2 continuous variables. Okay, so between 2 continuous variables, we are going to calculate the correlation. So we are going to calculate the correlation coefficient, that is R value. Here the R will be in small letter only. Okay. And next one is to find out the correlation between home environment and academic achievement of boys and girls of 9th standard. So I'm going to take 2 continuous variables and I'm going to check the continuous variable against the discrete variable boys and girls. Okay. And second one is I'm going to check for more than 2 continuous variables, that is home environment, study habits and academic achievement alone. Okay, not for boys and girls. So academic achievement of 9th standard students. Okay. So the third objective is to find out the correlation home environment, study habits and academic achievement of 9th standard home environment. So I have dimensions for home environment. So what I'm going to do is, instead of the grand total of home environment, I'm going to correlate each and every dimensions of home environment against the academic achievement of 9th standard students. So that is my 4th objective. Okay, is it clear? Yes. So now, how to formulate the hypothesis for this objective? So in the place of to find out, you have to substitute there is no, because we are going to formulate the null hypothesis, that is non-directional hypothesis. Okay. Okay. So for the first objective, that is to find out the correlation between home environment and academic achievement of 9th standard students, the null hypothesis is there is no there is no significant correlation between home environment academic achievement of 9th standard students. That's it. Okay. So now let us check how to do the analysis for this objective and hypothesis. So let us discuss the analysis part one by one, not as a whole. Otherwise, you will get confused. So first, I'm going to do the correlation between home environment and academic achievement. Okay. So let me move to my SPSS. So for this, analyze. So already we discussed about descriptive statistics and compare is also over. And now we are going to correlation, that is correlate, biway correlate. Okay? So analyze, under analyze, correlate, under correlate, we have to check the biway. So now, as I told already, we have to do the correlation for two continuous variables. So for home environment grand total and for academic achievement, I'm going to do the correlation. So I have to shift the home environment grand total and academic achievement to the right hand side column. And we make sure we have checked with the Pearson. So Pearson, Kendall, Stowe, and Spearman. The other correlation technique is also available. Since we are doing with parametric test, we have to check with Pearson and two-tailed. Okay. So options, if you want mean and standard deviation value, you just check with this column. Otherwise, you can leave that. Okay. Okay. So this is my mean and standard deviation value of this is not needed. Okay. We want only this table. See, the Pearson correlation for home environment versus home environment will be one only. See, you are going to find the correlation for two same variables. Your R value will be one only. Okay. So for home environment grand total and home environment grand total, R value will be 1. But we are going to check the R value for grand total and academic achievement, right? So the home environment grand total and academic achievement, the R value is 0.522 and the significance two-tailed is what? 0.00. See here I have some difference of opinion. You know, many people I have seen that they used to take this p-value 0.00 and they will write they are accepting the hypothesis or rejecting the hypothesis. See, for correlation, we can't say we are accepting or rejecting. We have to say whether the correlation is weak or strong. You can't say the correlation is accepted or rejected. Can you able to understand my point? So, we are not supposed to write the interpretation with the help of p-value only for this correlation technique. Then with the help of what we are supposed to write. So for that, can you able to see my screen, Google screen? Yes?
Yes, ma'am.
Thank you. Your correlation interpretation table. Okay, let it be. Go to images. Yes. See, if the R value is between 0 to 0.1, the correlation is very weak. If the R value is between 0.2 to 0.3, it is weak. If the R value is between 0.5, the correlation is moderate, medium. And if the R value is between 0.6 to 0.7, it is strong. And if the R value is between 0.8 to 1, it is very strong. So let us check this table. So this one is something I can compare with the previous one. See, plus or minus, either it is plus or minus. If it is from 0 to -3 also, it is negligible correlation. Okay. If it is 0 to 5 or minus 3 to 5, sorry, 3 to 5 or minus 0.3 to 0.5, it is low positive correlation or low negative correlation. If it is in negative, you have to write low negative correlation. If the values are in positive, you have to write low positive correlation. Similarly, if it is between 0.5 to 0.7, moderate positive correlation. If it is a negative, that is minus 0.5 to minus 0.7, it is negative positive correlation. Similarly, for high positive correlation, high negative correlation, and very high positive correlation and very high negative correlation. So you are going to write the interpretation for R value with the help of this value, not with the help of the P value. Just like that, you can't say there is no significant relationship or there is significant relationship. You have to say what kind of relationship, how it is correlated, whether it is weakly correlated or strongly correlated or positively correlated or negatively correlated or negligible correlation. You should not say there is no correlation. It is negligible correlation. Okay. So with the help of this table only, we are going to interpret the R value. So now let me move to the output. So now what is the R value here? It is 0.5. So it is 0.5 means what will be the interpretation here for 0.5? Yes? Can anyone give the answer in the chat box? 0.5? Yes, positive moderate correlation. Thank you, Kishore. Okay, because one more time, I'll go to the Google. You can check. So it is 0.5. It is between 0.5 to 0.7. So it is moderate positive correlation. Okay, so now let me go to my. So here, what is the R value for home environment and academic achievement? It is 0.5. I don't know the exact value. 0.522. Okay. Okay, 0.52. So under remarks, you are supposed to write moderate positive correlation. So how you are supposed to write interpretation? That, as I told here, we are not going to use the p value. So we are not going to accept or reject the null hypothesis. So I'm going to write the interpretation like this. That exists a moderate positive correlation between home environment and academic achievement of 9th standard students. Okay, this is how we are supposed to write the interpretation for correlation. So we know the R value, and with the help of this R value, you check the table, interpretation table, and write whether it is moderate or high or low. And then you write the interpretation. There exists a moderate positive correlation between home environment and academic achievement of 9th standard students. So that's all. Is that clear? If it is clear, I will move to the next objective. Come on. Yes. Thank you, Ambika. So next we are moving to the next objective 2. Okay. So to find out the correlation between home environment and academic achievement of boys and girls of 9th standard. And the hypothesis goes like this, that is, there is no significant correlation between home environment and academic achievement of boys and girls of 9th standard. So for this, what I have to do is, I have to split the subgroup. That is, under gender, we have 2 subgroups, boys and girls. So first I have to split the boys and girls, and I will be calculating the correlation separately for boys and separately for girls. Okay, let us see how we are supposed to do that. Okay, so here, so in SPSS, go to data. Under data, we have select cases. Okay, so data and then select cases. Here, I'm going to condition. I want only the boys. Okay, so You just check the if condition is satisfied. Okay, and then check this if and drag the gender. Just shift the gender to the empty column, and for gender, I want only boys. Okay, so for boys, what value I have assigned? We have assigned values for boys and girls, right? Can anyone tell me what value we have assigned for boys? Are you there? Yes. Okay, thank you, Jagannathan. So we have assigned 1 for boys, right? So you just type equal to 1. Because now I'm going to split the boys and I'm going to do the correlation for only boys. Okay, so continue and then okay. So now as such, you're going to do the analysis part. Analysis, correlation, bivariate, so total and grand environment and academic achievement. As such, I'm not going to you check the result here. Now it is only for boys. How we came to know that we have done the correlation only for boys? If you check the previous table, what is the n value here? Here the n value is 400. So the total number of samples is, the sample size is 400. But for this table, if you check the n value, it is 212, which means what? We have taken only the boys and we have correlated the grand total of home environment and academic achievement. Is that clear? So now the value is 0.515. Okay, what is the R value here? 0.51. So for boys, the R value is 0.51. Okay, so it is positive moderate correlation. Okay, positive moderate correlation. Let it be in simple form. Okay, so next. Similarly, now I'm going to do for girls. So again, go to data. Just check it because gender we have given 1. Next, I have to give 2 in the place of 1. So continue. Okay, and then go to analyze, correlate, bivariate. Okay. Now if you check the gender, we have done the correlation only for girls. So now the correlation value is 0.47. So the correlation value is 0.47. So if it is 0.47, what it interprets? If it is between 0.3 to 5, it is low positive correlation. Okay. So here you are supposed to write low positive correlation. Okay. So from this table, it is evident that the home environment favors the academic achievement for boys, and the home environment is not favoring the academic achievement of girls. So this is how we can interpret the result under the table. Okay. So from the R value, it is inferred that there exists a positive moderate correlation for home environment and academic achievement of girls. And for the second one, there exists a low positive correlation between home environment and academic achievement of girls. Is that clear? Because due to time constraint, I'm not typing the interpretation. So if it is clear, I will move on to the next one. Okay. Thank you, Ambila. Thank you. Thank you, Shana. So this part is over. Okay. So the second objective is over. Next, we are moving to the third one. So the third objective is, yes. So the third objective is to find out the correlation among home environment, study habits, and academic achievement of 9th standard students. And there is no correlation among home environment, study habits, and academic achievement of 9th standard students. See, instead of doing home environment, home environment and academic achievement, home environment, study habits, and academic achievement, we can put everything together, and in the table we can segregate the variables. Okay, so let's check how to do this. So let me move to my analyze, compare means, sorry, not compare means, correlate, bivariate correlation. In addition to home environment, grand total, and academic achievement, I am going to shift the study habits to the right hand column. That's it. Okay. The rest of the things are as such. Go to OK. So now we get the result. See, for home environment grand total and home environment grand total, the R value is 1. That is well understood. And for home environment grand total and academic achievement, the R value is 0.4, which means it is positively low positive correlation. Right? And if we check it for study habits, see, for home grand total and study habits, the R value is yes. Yes. So study habits and academic achievement, the R is the R value, it is minus. It shows that the study habits and academic achievement is negatively correlated. Okay, both are negatively correlated. So let me go to the table now. Okay, we are running out of time. Yes, here is the table. So you have to write the R value for home environment and academic achievement. So that is 0.4 something. And similarly for study habits academic achievement, it is minus 0.6 something, not 6, 0.016. What is this? It is 0.64. 0.6. So here you will be writing there exists a positive low correlation between home environment and academic achievement. So when there is when we put multiple correlation, it comes like this. Okay, and similarly here it is negligible correlation. Okay, so just like the previous table, here you are supposed to write the interpretation. So now let me go to the fourth objective. The fourth objective is to find out the correlation between home environment and its dimensions and academic achievement of 9th standard students. And the equivalent null hypothesis is there is no significant correlation between home environment and its dimensions and academic achievement of 9th standard students. Okay, so for this, so go to analyze, correlate, bivariate. What you're supposed to do is, I'm going to drag the study habits to the left-hand side column. Instead of that, I'm going to take all the 5 dimensions of home environment into the right-hand side column. Okay, you want, and then the rest of the things are same. So what I did, because here I want to do the correlation for home environment dimensions and academic achievement, right? So click OK. So here you get the value, that is R value. So the Pearson correlation value for home environment and academic achievement, it is 0.47. For home environment, this is not needed, right? Let me check this one. Yeah, for dimension 1 and academic achievement, the value is 0.3. For dimension 2 and academic achievement, the value is 0.4. For dimension 3 and academic achievement, the value is 0.3. And for dimension 4 and academic achievement, the value is 0.46. For dimension 5 and academic achievement, the value is R value is 0.19. Now tell me, among the 5 dimensions, which dimension is something more correlated with academic achievement? Can you type in the chat box? Yes. Second, which is second dimension? Okay, Ambika says it's second dimension. Any other answer? Fourth dimension. Yes, absolutely correct. Yes, Ambika, it is fourth. Because for fourth dimension, the R value is 0.4. But for second one, it is 0.3. Hence, among the four, like that, we can find out among the 5 dimensions, which dimension is highly correlated with the academic achievement of the students. So, this is how the same, the rest of the things are same. Okay, you just copy down the R value here. This is home environment dimension 1 and academic achievement. You have to copy the value here. And for this is for dimension 2, dimension 3, dimension 4, and dimension 5. And you write the remark, whether it is for moderate positive correlation or negative moderate correlation, whatever comes, you write the remarks here and you write the inferences under the table. Okay, with that, this is over. So the correlation, we have seen how to do the bivariate correlation in for different 4 objectives we have taken, and how to formulate the objectives, and also how to formulate the hypothesis we have discussed, and how to do the analysis for these 4 different objectives we have done with that. Okay. So if you have any clarification, we can. Why not? Because more than the dimensions, the total is highly correlated. Okay. So of course, we have to do the correlation for the total. Okay. Any other doubt? Oh, in the chat box, you're clarifying your doubts among yourself. I'm very happy. Partial correlation, multiple correlation. Okay, I will tell you how to do the partial correlation. So multiple correlation, I don't know. We don't have time. So I will wind up the session by partial correlation. Okay. Let us, because I have the PPT, I prepared the slides for positive correlation. Discuss that alone now. Okay. So in partial correlation, what we will be doing, there must be a continuous variable. Okay, for partial correlation, see, biserial correlation, 2 variables, right? But for partial correlation, we are supposed to take 3 variables, and all the 3 variables should have normal distribution. And the relationship, see, unless and otherwise there exists a correlation between 2 variables, we can't do partial correlation. Okay, so I'll tell you why at the end of the presentation. Okay? And the objective is to find out the positive correlation between home environment and academic achievement of 9th standard students by partially out the effect of study habits. Similarly, there is no, the null hypothesis is there is no significant partial correlation between home environment and academic achievement of 9 students by partially out the effect of study habits. So, what actually I'm going to do in multiple correlations, we will be correlating all the 3 variables together, right? But here, I am going to do the correlation only for home environment and academic achievement by partial out the study habits. For example, we have 3 friends, and we think that the 3rd friend is influencing the decisions of the other 2 friends. So what I will do, I will make her to sit in some other room, and I will ask the decision of these 2 girls. Okay, so this is what partial out. So what we are going to do, we are going to correlate the 2 variables by controlling the 3rd variable or partially out the 3rd variable. So that is called positive correlation. Okay, so let me see. Here I have taken 3 variables: home environment, academic achievement, and study habits. If suppose, if I'm going to partial out the study habits, it is R 13.3, which means I'm going to find the correlation between 1 and 2, partial outing the third variable, that is study habits. Similarly, I can do for 1 and 3, that is home environment and study habits, partial outing the academic achievement of the students. And similarly, we can correlate the academic achievement and study habits of the students, partial outing the home environment. So these three possible ways are there to do the partial correlation. Okay. So now let me show only one analysis. That is R12.3. Okay. So analyze correlation. So now we have to move to partial correlation. Okay. So previous analysis and all we did with the help of bivariate correlation, and now we are going to partial correlation. So correlate and check with this partial. So here I'm going to find the correlation between home environment and academic achievement. So I'm going to shift that to the variable column, and I'm going to partial out or control the study habits. So just shift the study habits to the controlling for column. Okay, and the rest of the things are same. So go to okay. So now we are getting the correlation value of achievement, that is 0.46 by partial outing the study habits. Previously, we have calculated the correlation for home environment and academic achievement. There, what is the R value for home environment and academic achievement? Yes. See, for home environment grand total and academic achievement, the R value is 0.5. But when we partial out the study habits here, the R value changes. When we control the study habit, the R value is 0.4, because so it clearly shows the study habit is also enhancing the academic achievement of the students. Okay. So now what we are supposed to do? You just write the R value here. This is for R12.3 and write the remarks. Okay. One remark, only one remark it will come, 3. So whether it is low positive correlation. Okay. So it is coming around 0.4. So you have to write low positive correlation. So there exists low positive correlation between home environment and academic achievement of 9th standard students by controlling or partial of the effect of study habits. So that's all. Okay. So with that, I completed correlation. So in today's class, we discuss how to check the normality for the country and then the correlation techniques. Okay. If you have any doubts, then clarify. See, both you can use Kendall-Towns as well as rank correlation. Both are non-parametric test ones. So you can use both. Okay. You can go for Spearman rank correlation, or you can discuss with your guide and you can choose either Kendall-Towns or rank correlation. Reference book, Garrett, many statistics books are there, See, usually I won't give any reference book for the students because they will stick on to that book alone. I used to ask the students to start with, you go with Indian authors, don't go with foreign authors, because it will be difficult for you to understand the language. So first our objective is to understand the concept. So go with simple language books and understand the concept, and then go to some advanced level books. So start initially to understand the statistical techniques. You should start with simple books, Kotari, Y.P. Agarwal book. Okay, and then you can go to Indian authors book. Very good. So start with Indian authors book. Once you become very familiar with the books, Y.P. Agarwal, Kotari books, these are good only. Okay, for theoretical aspects, you can use John W. Best and Morrison book. That is good for theoretical aspects. For statistics, these books will be good to follow. And Garrett, foreign authors book, Garrett is it is very good. Any book for SPSS? I have no idea for SPSS. Yes, yes.
Ma'am, there is a question from YouTube from Subramanian Kumar.
Yes.
Explain about mediation and moderation analysis.
Where it is?
From YouTube, ma'am. YouTube. Mr. K. Balasubramanian Kumar, he has raised one question about mediation and moderation analysis.
Mediation, moderate analysis.
Yes, ma'am.
See, actually, we won't be doing that analysis. We will be doing p-test, f-test, correlation, regression analysis only. So, seriously speaking, to be very frank, I don't have much idea about those analysis. Okay. And one more thing, really, I would like to share that is, see, most of the PhD students, after doing their correlation, they will straightly move to regression analysis. Don't do that. Okay. So, unless and otherwise, there is a strong correlation between and among the variables, you're not supposed to do the regression analysis, because in regression analysis, what you're going to do means you're going to predict the dependent variable from independent variable. For suppose I can predict the academic achievement of the students from the home environment. So this is what we actually do in regression analysis. Suppose your correlation itself shows that the correlation is very moderate and weak. If the correlation between academic achievement and home environment is very weak, then how can you predict the academic achievement of the students from home environment? So that is baseless. It is it is wrong. If that the correlation is weak or if the correlation is very low, don't go for regression analysis. Okay, that is not good. Say, I'll give you one example. Suppose we have 3 friends. Or let it be 2 friends. Okay. So 2 friends means only when we have same wavelength and same characteristics, we can be very close to each other. Right? Suppose I can predict you can predict my characteristics from my friend's characteristics because she's very close to me. Suppose one girl, she's not at all close to me and we are very opposite to each other. Can you able to predict my characteristics with the girl who is opposite to me? No. Right? So in that case, you can't do regression analysis. So please don't do that. If the correlation is weak or if the correlation is low, don't do regression analysis. Okay? See, we can't do all regression analysis based on your data and based on your what you actually want to do. You can do regression analysis. Okay. We can, whether you want to find out, you want to predict the dependent variable with joint contribution or with individual contribution. Based on that, you will be choosing your regression analysis. You no need to do all the types of regression analysis. It's not necessary also. Okay.
Shall we end up the session now?
Yes, ma'am.
Shall we end up the session now?
Yes, ma'am. Yes, ma'am. So I would like to thank the organizing committee members for giving me this opportunity, because really I would like to thank Dr. MGR Research Institute, Principal Geeta ma'am, and Sendamil Pave ma'am, a very good friend of mine, because they are often inviting me, and really I would like to thank them for trusting me. So thank you so much, ma'am, for giving me this opportunity again and again. So thank you so much. I'm very happy to be associated with your institution. Thank you. And
Thank
also,
you,
I would like to thank the audience, the participants, because they are very, very active. They are giving so many answers in the chat box. Even I keep on asking questions. I don't know whether I disturb them, but still they answer all my questions in the chat box. So thank you so much for the patience listening. Thank you all.
Thank you, ma'am. You are expertise.
Yes, ma'am.
Your expertise and insights made the workshop an incredibly enriching experience for all the participants. We truly appreciate the time and effort you dedicated to ensuring the workshop's success. Your passion for the subject was evident, and your patience in addressing our queries was commendable. Your contributions have made a lasting impact, and we are genuinely grateful for the opportunity to learn from you, ma'am. Really, thanks for accepting our invitation for host the workshop for past 3 days. Thanks a lot, ma'am.
Thank you.
Now I
Thank you.
request
My pleasure.
my Mrs. Sabital to propose the vote of thanks. Sabital, unmute yourself.
Good evening to one and all present here. As all good things come to an end in life, so as the workshop. On behalf of Faculty of Education, Dr. MGR Educational and Research Institute, I deem it a great honor to propose the vote of thanks to all who have been a part and helped us in making this 3 days workshop on SPSS such a resounding success. First of all, I would like to propose my hearty gratitude to our resource person, Dr. A. Shyamala Devi, Assistant Professor, University of Madras, for gracing the workshop on SPSS. It really means a lot to us, ma'am. You have surely added a charm to this event with your patience explanation, starting from the basic concepts of research, what is SPSS, how to create it, and you explained about the various tests and its significance, values, ANOVA, and product moment correlation with law. Really trained and guided us to perform perfectly for our future endeavors. Thank you so much, ma'am. I would like to thank our Honorable President Engineer ACS Arun Kumar for granting us permission to organize this program. I thank all the executives and head of our institution. I would like to extend my sincere thanks to Dr. K. Geeta, Principal Ma'am, Faculty of Education, Dr. MGR Educational and Research Institute for our initiative and guidance towards this workshop. I thank all the faculty members of Department of Education of Dr. MGR Educational and Research Institute for their dedication and efforts for this 3-day workshop. I thank all the participants from various institutions for paying your valuable attention and also suggesting with your opinions. Hope you all have gained knowledge and understanding on SPSS. Now the feedback forms will be shared in the chat box. It will be activated only for 15 to 20 minutes. Kindly fill it. Thank you all once again. Thank you.
Thank you.
Thank you, Shyamala ma'am. Thank you so much. Whenever we are calling, you are accepting our invitation. Thank you so much, ma'am.
Thank you, ma'am. It's my pleasure. Thank you.
Thank you, ma'am.